Hi everyone, we're Group 4 and this is Fan. Today we'll present on automation and human error. We will start to introduce some important background information. What is human error? How automation was invented and the pros and cons of automation. The term human error was first coined in the 1940s during an aircraft accident investigation. As its name implies, however, it has been happening since human existence. Human error is officially defined as something having been done that was not intended by the actor, not desired by a set of rules or an external observer, or that led the task or system outside its acceptable limits. In short, it is a deviation from intention, expectation, or desirability. There are many types of human error. Some most frequent ones are physical manipulation error and active error. Those two are related to physical interactions of humans. And the another one is team error. It refers to lack of vigilance created by the social interaction between two or more people working together. There are many controversies about the cause of human error. Researchers found that human errors are usually related to limits of memory and attention, cognitive biases, and misunderstanding in human communication. The other key word today is automation. Automation is also called labor-saving technology, which allows a process or procedure to be performed with minimal human assistance. Some examples of automation are processes in factories, switching on telephone networks, steering and stabilization of ships, aircraft, and other applications and vehicles with minimal or reduced human intervention. What are the advantages of automation? First, it obviously increases the productivity and quality of products. It also improves the robustness and consistency of productions or processes. Additionally, it reduces direct human labor costs and expenses. We can see the benefits brought by automation is enormous, but automation is not perfect. It also has disadvantages. One issue is the high initial cost to set up the required equipment and the production line. It also leads to unemployment problems for society since it replaces workers with automated systems. Next, Jiazi will be talking about how automation can help mitigate human error.
Nowadays, many organizations are using automation to reduce human errors in making repeated tasks, for example, IT staff, to promote productivity and for bigger success in the company. Automation can effectively monitor tasks to reduce risks and bugs that are caused by human error. For example, Amazon Web Services, also known as AWS, S3 outage caused by human error could be prevented by automated monitoring. As companies grow bigger and the workload for data gets very large, it is very important to use automated monitoring. And automating IT process is the key to outage reduction. Organizations need to explore ways to reduce downtime for internet pages. According to study, 22% attributed to human error. Here are things to consider. A single source of truth. If we set up it correctly, automation can greatly increase the likelihood of identifying small issues before they get way worse. Improve accountability with automation. The whole process of reviewing a system's health is reliable, so it provides a clear timeline of previous commits. Scale ready. As companies scale up, the risk of human error also increases. When a company managing more than 10,000 devices, it is inevitable to encounter error. But with automation, it will provide a level of consistency for the whole process. Added business value. With the constant emerge of new technologies, it is very challenging for companies to stay in the trend today. Automation can free up IT staff's time that they can be used for other stuff, such as customer service, increase productivity, automate, automating monitoring and other process helps control costs so that there is few manual tasks to complete. Human error can be reduced. We know that some degree for human error is inevitable, but implementing automated monitoring in the IT environment is a productive step for the risk caused by human error. Automation has so many good sides that it should be considered as an essential part of any organization's success.
So, as we all know, research on human interaction with automated systems is extensive. Our current objective here is to understand how various factors and how well an individual would be managing automation. So, as we know, automation provides high performance and efficiency on any kinds of product. Uh, that does not necessarily mean that high reliability on automation is our solution. Things could be worse if there is no support to automation in case of errors. So this is a basic concept, the basic concept of automation bias. Now, automation errors may include misses and false alarms, misdiagnosis, inappropriate action implementation. Automation designers know that certain errors, such as these misses, will occur when they set a threshold for detection, and uh, the worst case failures might also occur. So, since we're dealing with automation or automated systems, why do we have these errors? We can basically classify these errors into four categories: automation variables, person variables, task variables, and emergent variables. So, automation variables basically include the characteristics of automation, such as reliability of automation, types of errors automation is likely to make, the level of automation, and the nature of feedback the automation provides to the human operator. Person variables represent factors that are unique to the individuals and include an individual's complacency potential and the nature of training received for the automation and the knowledge that the user has regarding the automation. Task variables would include variables that are described in context where the humans and automation are working together. So that would be, let's say, the costs associated with verifying automation suggestions or information, the degree of human involvement in the automation, and lastly, we come lastly to the emergent variables, which are generally described as the factors that result from the interaction between human and the automation. So, talking about automation errors, why are there errors when the system is programmed to do the task? It could be that perspectives regarding errors have shifted due in part to the distinctions of errors and their consequences. But our goal here for is not error prevention but error management, or we should limit the consequences of the error that we are facing. So we have these three components that helps us with error management. The first one would be detection, which involves realizing that something has gone wrong and that an error is about to occur. Explanation is basically the process of identifying the nature of error as well as understanding the underlying cause for the error. Correction involves modifying the existing plan or developing a new plan as a countermeasure against the potential adverse effects of the error on the system. So now progression through these three phases is not necessarily linear, and we might have some overlaps in the detection, explanation, correlation phase, but corrective measures can be taken while we are attempting to solve our problem. But in a time restricted situation, operator may take action to correct the error without really understanding the underlying cause. So now for error management, we have to follow some error modeling procedures. So to further understand the processes involved in the three phases, we have this generic error modeling system. So this is how it goes. After a problem has been detected in our system, our behavior transitions from monitoring the problem to solving the problem. Now, the first attempt at problem solving occurs at a rule based level where an individual will search for the applicable pre established corrective procedure to solve the problem. If our stored procedure actually resolves the problem, we continue towards our goal. But if the stored procedure is not sufficient, our behavior proceeds to the knowledge based level. Now, at the knowledge based level, problem solving may occur through the use of analogies, mental models, or abstract relationships. Now, the explanation phase of our framework follows that individuals search for familiar patterns to compare their current situation to. In interaction with automation, operators may similarly examine their memory of previous automation errors for a comparable event and apply stored rules as a mean of correction. If such a pattern is not available, the explanation phase contains how individuals use their mental representation of the problem space or of the automation, in our case, to make explanatory connections.
Artificial intelligence in automation. It is a complementary technology designed to enhance the performance of instruments and humans, such as managers, consultants, engineers, and technicians, in doing their jobs. And the one reason for artificial intelligence to exist is to avoid direct human intervention so that the human error can be eliminated. And nowadays, this technology is getting very commonplace. In a study performed by Vaisman, which is an independent and specialist market research provider for the global technology sector, named human error as the number one reason for manufacturing and production losses. They found out that the human error constitutes 23% of unplanned downtime and the production losses. Now, let's take a look at the most critical factors for human errors. First, the procedure related errors. These types of errors are associated with the poorly written procedures, incomplete instructions, and the worker's decision not to follow them. On the other hand, when unexpected situations arise, most of the solutions for emergency intervention are not listed as part of these set of instructions. To select the best course of action, multiple variables need to be detected and analyzed. AI can certainly help in this area, but past experiences tell us that the most failures are a result of new circumstances not predicted by the technical professionals that require the capacity of analysis of infinite possibilities, and we will need a human to respond. Second, the cognitive overload. Stress, fatigue, illness all have a negative impact on our attention, memory, and decision making process. This factor can indeed be eliminated with the artificial intelligence. Last, the system design. The only thing that could cause AI to misbehave is the human error, because we human designed AI. The programmers spend more than 20% of their time performing debugging tests. Those tests are intended to identify the weaknesses in the system. Our experience with these exercises is not how rigorous they are, more than what is it they are testing, and of course the human who creates them. For example, with the technology becoming more and more complex, it is now getting more and more difficult for humans to keep software safe. As demonstrated by the Tesla autopilot car crash, the human error is to blame more than bad AI. In this case, autopilot sensors failed to distinguish a white trailer against a bright sky, and something we can now attribute to human error within the code. Daily life is plagued with human errors. It is estimated that we make mistakes every other minute. Some estimate that a person will make close to 800,000 decisions over a lifetime, and that will come to regret 150,000. Even though AI and the technology address most of the process variability and improve some weaknesses, there is still one gap: the human, the very one that started it all. So, is the AI solution for human error, or human error the new AI problem in automation? Certainly, the time will tell.
Having understood the definition of human error and automation, seeing how it can be used in the IT scenario, understanding automation error and ways to manage it, and exploring the relation of human error and AI. We'll conclude by looking into the future. As we look into the future, technological advances in human machine interaction, automation, artificial intelligence, and related disciplines are likely to usher in dramatic change in how we live with automated machines. Although such radical shifts are hard to predict, some suggestions and trends are noticeable. One change imagined by Yuval Noah Harari in his book 21 Lessons for the 21st Century, he envisions a world in which AI will become better than we are at many tasks. If this happens, then one question for automation will be how human users can best use such super smart AI. Will the humans enjoy the interactions and engage in them? Will they engage with AI while having the appropriate level of trust, taking into account both the benefits and potential costs of automation? Or will they act like the humans in Asimov's novel Caves of Steel, where the people of Earth of about 1,000 years in the future fear and reject robots and the comforts that robots can provide humanity? Another dramatic change is envisioned by futurist Mark Pesce. Now, Pesce expects that we will be able to associate digital data with physical objects and view this data through augmented reality glasses. Pesce expects that this will lead to the emergence of what he calls super tools, tools that can allow us to interact with computing objects and thus with the automation around us, while having at our disposal vast amounts of data and all aspects of the work of automation. This is a scenario where automation will simply aid human actions and hence reduce chances of error. Turning to art again, and specifically the science fiction of Asimov, imagine what it might be like to interact with automation if our interface technologies can go beyond showing us information with augmented reality. What if the automation could make us feel like the machine is an extension of our body? This is what it feels to operate an advanced starship in Asimov's Foundation's Edge. The effort required to accomplish something is about as much as to think about the goal. Perhaps Asimov overestimated the probability that machines will eventually be able to literally read our minds. But we can still expect that our minds and the machine automation will not always be separated by keyboards, screens, and brittle speech interfaces. How will radically more capable interfaces affect how we can control automation, and just as importantly, how we can perceive automation and its place in our lives? As we contemplate the inevitable radical changes in human automation, it is important to keep asking questions. What are the economic and societal forces that are driving the changes? How will new technologies shape what is possible for these interactions? And where are the economic and broad societal implications of these dramatic changes? The answers to these questions will be found through interdisciplinary work that incorporates a clear understanding of human automation interaction and leverages it effectively. Many previous eras of human development have included radical change in technology, but we expect the change to be faster than it had ever been in the past. Where will this change in automation lead us? This is it for Group 4. Thank you for watching.